Imagine standing in the middle of a massive, enterprise data center.
Oh, yeah, freezing cold.
Exactly. The air conditioning is just blasting, and the ambient noise from, thousands of cooling fans is absolutely deafening. Everywhere you look, there are endless rows of blinking lights humming away, processing millions of transactions a second.
Right. It's an incredible environment.
It is. But now imagine one of those machines, buried in Rack 42, just starts failing. But here's the catch. You aren't in that freezing room. You are sitting at your kitchen table, 1,000 miles away, drinking a cup of coffee.
Oof.
How on earth do you fix it?
Honestly, it sounds like magic to anyone who hasn't done it, but it is actually a masterpiece of modern engineering. You aren't just remoting into a desktop,
Right.
You are controlling bare metal hardware across the country. And pulling that off without causing a catastrophic outage requires a very specific, highly orchestrated set of tools.
Well, welcome to the deep dive. Our mission today is demystifying the D-PE-OE-01 exam.
The big one.
Yeah, this is the official certification for managing Dell PowerEdge servers. We are using a stack of official prep materials and practice questions to really crack open the logic of how these massive server environments actually function.
Which is so important because, to master the D-PE-OE-01, you can't just memorize flashcards. You have to understand the entire lifespan of a server.
Right. The exam blueprint actually maps perfectly to the reality of working in enterprise IT, doesn't it?
It really does. You have to know how to deploy and control these machines remotely, which makes up about 22% of your score for server management. Then you have server monitoring and system administration, each making up 20%.
Keeping the lights on, basically.
Exactly, keeping the lights on and securing the system. Then server maintenance is another 16% for updates and decommissioning. And finally, troubleshooting rounds out the last 22% for when things, inevitably catch on fire.
Which they always do. And even if you aren't sitting down to take the D-PE-OE-01 tomorrow morning, this deep dive is the ultimate crash course in enterprise IT logic.
Absolutely.
And to make sure you get the absolute most out of this, we have a strict rule for today. I am going to read every single practice question and the full text of every single option, A, B, C, and D, completely aloud verbatim.
Oh, that's a great idea.
Yeah, that way you can play along, test your own intuition, and see if you can spot the trap before we break down the underlying logic behind every single choice.
Which is the absolute best way to learn this material. Because in the field, knowing exactly why a tempting answer is wrong is often what saves your network from going down.
For real. So let's jump right into that remote control scenario. How do you command a blank machine from 1,000 miles away? Here is our first practice question.
Let's hear it.
In the context of server maintenance, what role does the iDRAC virtual media feature serve? Option A, it streams diagnostic videos directly to the administrator. Option B, it allows the server to boot from an operating system image located on the administrator's local machine. Option C, it automatically backups the server's hard drives to the cloud. Option D, it acts as a shared storage repository for multiple servers.
Okay, lot to unpack there.
Yeah, okay, let's unpack this. Before we even look at the options, if someone is new to this ecosystem, what exactly is iDRA?
That is the perfect place to start. So iDRC stands for Integrated Dell Remote Access Controller. Think of it as a tiny separate computer built inside the main server.
So it's completely independent.
Pretty much. It has its own processor, its own network connection, and it runs on auxiliary power. So even if the main server is completely powered off or doesn't even have an operating system yet, you can still log into iDRC.
Oh, wow. So you still have control of the physical hardware.
Exactly.
Got it. So I am sitting at my kitchen table, log into iDRA, and I need to install Windows or Linux onto this blank server in a data center. Option A talks about streaming diagnostic videos. Is this like a Netflix feed for server errors?
Not at all. That is a fundamental misunderstanding of the tool. iDRC gives you a virtual console, which shows you the screen output, but virtual media specifically is not a video streaming service.
Okay, so A is out. What about C and D?
Right, so option C, cloud backups, and option D, shared storage, are completely different technologies altogether. Those handle data at rest, like an Amazon S3 bucket or a local storage array.
So virtual media doesn't store your daily files.
Right, doesn't do that.
Which leaves option B. It allows the server to boot from an operating system image located on the administrator's local machine.
So am I essentially spoofing a physical connection? Is it like a really long HDMI cable?
Yeah, you are essentially tricking the hardware. Option B is correct. If you have an installation file sitting on your laptop at home, iDRAC Virtual Media takes that file and presents it to the server over the network, as if you were standing right there.
Exactly, as if you just physically walked into the data center and plugged a USB thumb drive directly into the front of the machine. The server's motherboard doesn't know the difference.
That is wild.
It really is. It reads the file, boots up, and installs the operating system. It is the absolute cornerstone of remote deployment.
That is brilliantly deceptive engineering. But that's just one server. What happens when your company buys 50 new servers at once?
That's where things get complicated.
Right. Let's look at how we scale this up with our next question. In Open Manage Enterprise, what mechanism is used to group servers dynamically based on specific criteria, such as location or hardware type?
Okay.
Option A, static tags. Option B, compliance baselines. Option C, query groups. Option D, configuration templates.
Good question.
I'll be honest, the word jumping out at me here is dynamically. But real quick, Open Manage Enterprise, how does that differ from iDRA?
Great distinction. So iDRJ is a one-to-one relationship. You log into one iDRC to manage one specific server. Open Manage Enterprise, though, is your central command tower. Yeah, it is a software console that can discover and manage thousands of iDRACs simultaneously across your entire global network.
Okay, so I am looking at thousands of servers in Open Manage. If I'm the administrator, I want my 50 new Chicago data center servers organized together. Why not just drag and drop them into a folder? Or use Option A, static tags.
Well, because human beings are terrible at repetitive tasks. If you use Option A, static tags, you have to manually tag every single new machine.
Which sounds exhausting.
It is. And what happens when a server gets physically moved from Chicago to New York 6 months from now? A human has to remember to go in and update the tag.
Oh, and if they forget, your entire management system becomes inaccurate.
Exactly. Option A fails the dynamic requirement. Option B, compliance baselines, is about checking security rules against a known standard. It doesn't group devices.
Right, and Option D.
Option D, configuration templates, is a tool for pushing out settings, not organizing the machines.
Which brings us to Option C, query groups. So this acts like a smart filter.
Exactly. Option C is correct. You set up a logic rule in Open Manage. You tell it, hey, if any server boots up anywhere in the world and its internal location data says Chicago, automatically place it in the Chicago group.
Oh, I see. There is no manual tagging at all.
None. If the server moves, it automatically leaves the group. It entirely removes human error from your inventory management.
So we figured out how to deploy a server and automatically organize it. But what happens at the end of that server's life?
The decommissioning phase.
Exactly. When it's time to pull the plug and get rid of the hardware, how do you make sure your company's proprietary data doesn't walk out the door? Let's look at a critical piece of server maintenance with our third practice question.
Lay it on me.
When decommissioning a PowerEdge server, which feature within the lifecycle controller securely removes all user data and configuration settings? Option A, factory reset. Option B, system erase. Option C, secure boot. Option D, data wipe protocol.
This one tricks a lot of people.
I can see why. Here's where it gets really interesting.
Yeah.
If you are listening right now, you might be looking at this list and thinking about corporate espionage or data leaks. Wouldn't a data wipe protocol, Option D, make the most sense by name? It just sounds incredibly official and secure. I would be deeply tempted to select D.
It sounds like something out of a spy movie, right? Which is exactly why the exam writers put it there. Option D is completely fabricated.
Wait, really? It's totally fake.
100%. It does not exist in the Dell ecosystem.
Okay, so I would have failed that one instantly. Good to know. What about Option C, secure boot?
Well, Secure Boot is actually a startup feature. When you turn a server on, Secure Boot checks the digital signatures of the operating system to make sure malicious malware hasn't hijacked the boot process.
Oh, so it prevents bad code from loading?
Right, but it has absolutely nothing to do with deleting data. So C is out.
That leaves factory reset and system erase. In my mind, a factory reset wipes my smartphone clean before I sell it. Why wouldn't Option A work here?
Because a standard factory reset, Option A, generally just restores the software configurations back to their default state. It might delete the pointers to your data, you know?
But not the data itself.
Exactly. The underlying sensitive data like customer records, passwords, proprietary code is still sitting as physical magnetic or flash memory states on those drives. Someone with data recovery software could extract it easily.
Yikes. So Option B, system erase, goes deeper.
Much deeper. Option B is correct. System erase utilizes cryptographic shredding. Modern enterprise drives are often inherently encrypted, right?
Okay.
So system erase doesn't just delete the files, it irrevocably destroys the encryption keys required to read the drives and then overwrites the configuration chips. Yeah, within seconds, terabytes of sensitive data become mathematically impossible to read. It turns the data into absolute garbage. When that hardware leaves your building, it is an empty, useless brick to anyone trying to mine it for secret.
Cryptographic shredding. That is fascinating. Speaking of things going horribly wrong, let's talk about the nightmare scenario every IT admin dreads.
Oh no, I know where this is going.
Yep. It's Friday at 4 p.m. You push a routine update to your servers, and the entire application environment crashes. Here is how the D-PE-OE-01 tests that exact moment.
A classic scenario.
If a recently applied firmware update causes instability, which feature allows the administrator to revert to the previously installed version without manual file uploads, Option A, disaster recovery profile. Option B, firmware rollback. Option C, snapshot restore. Option baseline remediation.
Important to clarify something first.
Sure, firmware isn't regular software, right?
Correct. Software, like your operating system, lives on the hard drives. Firmware is the low-level code permanently etched into the physical chips on the motherboard, the network cards, the power supplies.
It tells the raw hardware how to operate.
Exactly. If a firmware update is unstable, the physical machine teeters. The OS might blue screen, or the server might just randomly reboot.
And when you are panicking on a Friday afternoon, you don't have time to scour Dell's website trying to download the older version of the file to fix it.
Exactly. Let's eliminate the noise here. Option A, disaster recovery profile, is way too broad. That's a concept for rebuilding a completely destroyed environment, not fixing a buggy update.
Makes sense. What about snapshot restore?
Option C, snapshot restore, is incredibly tempting because we use snapshots all the time in virtual machines. But snapshots apply to the operating system, not the underlying bare metal hardware chips.
Ah, I see the distinction.
And option D, baseline remediation, is the act of pushing updates out to fix compliance issues, not undoing them.
So the system actually keeps a localized backup of the firmware.
Yes. What's fascinating here is firmware rollback, option B, is the correct answer. Modern enterprise servers have a dual-image firmware architecture.
Dual image?
Right. When you install a new firmware version, the server doesn't delete the old one. It simply shifts the old, stable version into a secondary memory bank.
Oh, that is so smart.
If the new update causes your server to crash, you log into iDRAC, hit firmware rollback, and the system instantly swaps back to the known good version. No downloads, no USB drives. It's an undo button for bare metal hardware.
I love that. So simple, but so effective. Okay, let's step away from the software and firmware for a minute and look at the physical bare metal logic. This is where we extract maximum performance. Let's look at memory architecture with question 5.
Hardware time.
When populating memory in a PowerEdge server for optimal performance, what is the general rule regarding memory channels? Option A, populate all available channels with identical memory modules. Option B, leave one channel empty for failover purposes. Option C, use different capacity modules across channels to maximize storage. Option D, populate the highest capacity modules in the last available slots.
This is a great architecture question.
Okay, if I am trying to visualize memory channels, is it kind of like putting identical tires on a sports car? You know, you wouldn't put two massive monster truck tires on the back and two tiny bicycle tires on the front. You want identical tires for maximum balance speed.
Well, the tire analogy is okay for visual balance, but a better way to understand the actual computational mechanics is to think of a massive grocery store.
A grocery store. Okay, I'm listening.
The server's processor is the store manager, and they are trying to process thousands of customers, which represents your data as fast as possible. The memory channels are the checkout lanes.
Okay, I'm with you.
The processor wants to divide the workload equally across every single checkout lane at the exact same time. This is called memory interleaving. Ah, memory interleaving, right. If you choose option B and leave one channel empty, you just close the checkout lane. Your data traffic instantly backs up.
So option B is terrible for performance.
Exactly. If you choose option C and use different capacities, or option D and load up the last slots, it's like putting a customer with 3 overflowing carts in the express lane and a customer with 1 item in a regular lane.
The processor has to wait for the slow lane to finish before it can move on to the next computational task.
Exactly. The processor can only move as fast as the slowest, most congested memory channel. That is why option A is the correct answer.
You populate all available channels with identical memory modules.
Yep. Every checkout lane processes data at the exact same speed, allowing the processor to sweep across all the memory simultaneously without ever waiting.
Identical modules across the board to prevent data traffic jams.
Yeah.
Got it. Now, what about power? Because the most perfectly optimized memory in the world means nothing if the server doesn't have electricity.
The ultimate truth of IT.
Let's look at question 6. Which power supply configuration ensures that the server continues to operate normally even if one entire power grid in the data center fails? Option A, non-redundant mode. Option B, performance mode. Option C, grid redundancy. Option D, power capping.
Okay, grid failure.
Let's frame the stakes here. A construction crew with a backhoe just dug up the street outside the data center, and they accidentally severed a main municipal power line. Half your data center instantly loses power.
That is a nightmare scenario, but believe me, it happens. If you configured your server with option A, non-redundant mode, your server just died hard. Any data currently in memory is permanently lost.
Ouch. What about performance mode?
Option B, performance mode, might optimize how power is drawn across the supplies during normal operation, but it won't save you from a complete blackout. And option D, power capping, is an artificial limit you set to stop the server from drawing too much electricity and spiking your utility bill. It has nothing to do with failover.
That leaves option C, grid redundancy. But I mean, if an entire power grid drops out, how does the server switch over to a backup without turning off for a few seconds to reboot? Even my house lights flicker when the generator kicks on.
Because there is no mechanical switch causing a delay. In a true enterprise data center, the building is wired to two completely separate city power grids, Grid A and Grid B.
Okay.
Your server has multiple power supplies physically plugged into both. Option C, grid redundancy, configures the server to pool that power internally. Both power supplies feed into a shared physical backplane on the motherboard simultaneously.
Oh, so they're both actively supplying power at the exact same time.
Exactly, they share the load. If the backhoe severs Grid A, the power supply connected to Grid A instantly drops to 0. But the power supply connected to Grid B is already connected to the shared backplane.
It just takes over.
It simply ramps up its output to carry the full load. There is 0 millisecond delay. The server doesn't blink, it doesn't reboot, it just keeps processing transactions as if nothing happened.
The physics of that are incredible. All right, let's move into system administration, which makes up 20% of the exam. Once the hardware is running perfectly and powered up, we have to protect it. Here is question 7.
Security time.
Which feature in iDRC ensures that a virtual console session is automatically terminated if the management interface remains inactive for a specific duration? Option A, idle timeout. Option B, session lockdown. Option C, connection limit. Option D, access control list.
Good practical question.
This immediately makes me think of logging into my mobile banking app. If I open it, check my balance, and then set my phone down on the counter and walk away, 3 minutes later, the app automatically logs me out.
It is the exact same logic, but with exponentially higher stakes. When you are logged into a virtual console, you have deep root-level access to the bare metal hardware of a server that might be running a Fortune 500 company's database.
Right, you can't just leave that open.
Exactly. If you get distracted and walk away from your desk, you cannot leave that door wide open for someone else to sit down and wreak havoc. Let's look at the distractors, though, because they are all valid security concepts.
Right, why wouldn't it be session lockdown? That sounds pretty secure.
Option B, session lockdown, restricts what kind of commands you can run during a session, but it doesn't necessarily terminate the session based on a timer. Option C, connection limit, just stops too many administrators from logging in at the exact same time.
And option D.
Option D, access control list, is your bouncer. It checks your credentials at the door to see if you are allowed in at all.
If leaves, option A, idle timeout, as the correct answer.
Correct. It is a fundamental, non-negotiable best practice for remote session security. After a set period of 0 mouse movements or keyboard strokes, it severs the connection.
Okay, question 8 takes security to a completely different level. Let's read it. What is the main effect of enabling system lockdown mode on a PowerEdge server via iDRAC? Option A, it physically locks the server bezel to prevent unauthorized access. Option B, it isolates the server from the production network. Option C, it pauses all virtual machines currently running on the host. Option D, it prevents configuration changes and firmware updates.
I love this one.
Okay, so I have to ask about option A. When we talk about system lockdown, are we talking about a physical mechanism? Like, do little metal bars literally slide into place over the hard drives?
I always laugh when I see option A on practice tests. While physical security is incredibly important, iDRAC is entirely a digital interface.
So no metal bars.
Sadly, no. It cannot magically manifest a physical metal padlock on the front of the server, so A is out.
What about isolating it from the network? Option B. Or pausing the virtual machines? Option C. If you are locked down, shouldn't you stop processing data?
No, because that defeats the entire purpose of an enterprise server. Isolating it from the network or pausing its virtual machines would cause a massive self-inflicted outage.
Oh, right. The users would be furious.
Exactly. The server needs to keep doing its job, serving web pages or processing databases.
But what does system lockdown actually do?
Option D is correct. It prevents configuration changes and firmware updates. Think of it as a digital read-only switch.
A read-only switch.
Yeah. Imagine you have a pristine, perfectly configured server. You turn on system lockdown. Suddenly, no one, not even an administrator with full credentials, can accidentally change a BIOS setting, format a drive, or push a risky firmware update.
But the users don't notice a thing.
Right. The server keeps serving data to your clients perfectly, but its core operating parameters are frozen. It is the ultimate protection against a rogue administrator or just an honest human mistake.
A read-only force field for the server's brain.
I like that.
Okay, we are entering our final act. Troubleshooting makes up a massive 22% of the D-PE-OE-01 exam.
The biggest chump.
Because despite our redundant power grids and our lockdowns, hardware operates in the physical world and eventually breaks. Here is question 9. What happens when a PowerEdge server triggers a critical hardware fault while Support Assist is fully configured and active?
Okay.
Option A, a support case is automatically created with Dell technical support. Option B, the server immediately powers down to prevent damage. Option C, all management ports are locked until an administrator logs in. Option D, the hypervisor is forced into maintenance mode.
Wait, so what exactly is Support Assist? Does the server essentially call its own doctor?
That is precisely what it does. Support Assist is a piece of telemetry software that constantly monitors the physical health of the components.
So it's always watching.
Yes. If we connect this to the bigger picture, this is the shift from reactive panicking to proactive management. Let's look at why the wrong answers are so dangerous here. Yeah, option B says the server immediately powers down to prevent damage. I mean, if a part is failing, shouldn't it turn off?
Absolutely not. In an enterprise environment, a server might have a failing cooling fan, but it can still limp along safely while routing user traffic to other systems.
So powering down is a bad idea.
If the server just unilaterally powers itself down, like in option B, it causes an immediate hard outage for your users. Option C, locking the management ports, is a terrible idea because it locks you out right when you need access to investigate.
And option D?
Option D, forcing maintenance mode, is highly disruptive to running workloads.
So option A is the proactive path.
Correct. The moment a part fails, say, a memory stick starts throwing uncorrectable errors. Support Assist gathers the exact error codes, securely contacts Dell's back-end systems over the internet, opens a support ticket with your service tag, and literally dispatches a replacement part.
Automatically.
Entirely automatically. Half the time, the IT administrator doesn't even know the server is broken until the delivery driver shows up at the data center holding the new memory stick.
That is the definition of efficiency. But what if the problem isn't a total catastrophic failure? What if the server is just acting weird? Let's look at our final question, question 10.
The intermittent errors. Always fun.
If a server is experiencing intermittent hardware errors, but the operating system remains functional, what is the safest initial step to diagnose the issue without physical access? Option A, immediately initiate a factory reset. Option B, generate and review a Support Assist collection. Option C, replace the power supply units. Option D, flash the system BIOS to the oldest available version.
What's your instinct here?
Well, I am going to play devil's advocate here.
Yeah.
If I am the administrator and my boss is screaming at me that the server keeps blipping offline, why not just swap the power supply like option C says? Get the suspected bad part out of there immediately. Generating a log file feels like I'm just sitting on my hands doing nothing.
I get the temptation. You really want to take action. But in a massive data center, blind guessing is incredibly expensive.
Expensive how?
Replacing a power supply, option C, means you are paying for hardware you might not actually need, and more importantly, you have to schedule downtime to physically swap it out. Data center managers hate unnecessary downtime.
So precision over panic. What about the other distractors?
Option A, a factory reset, is wildly destructive as a first step. You would wipe out all your complex configurations just to chase an intermittent error.
That would be a career-limiting move.
Oh, definitely. And option D, downgrading the BIOS to the oldest version, is a fantastic way to introduce a dozen new security vulnerabilities and completely brick the system's compatibility with modern operating systems.
So option B is the only logical choice. Generate a support assist collection.
Correct. Because the operating system is still functional, you have a window of time. A support assist collection is a massively detailed zip file containing all the system logs, the hidden error reports, and the hardware telemetry.
So you don't even have to be in the room.
Right. You pull that collection remotely, you analyze the data, and you find the exact root cause without ever physically touching the server. It prevents you from guessing, and it dictates the exact right fix.
Thank you so much for joining us on this deep dive. Keep asking questions, keep unpacking the logic, and we will catch you on the next one.